Greetings, my name is Shubham Pokhriyal and today we are going to learn stack. So, if I talk about stack, mm, let us imagine a bucket. And first I put a red color t-shirt in that bucket, and then green color t-shirt, and then uh, my purple color t-shirt, and then my cyan color t-shirt. If I want to pick a t-shirt from this bucket, eventually I will have to pick the t-shirt which is on the top, this one. So this means the t-shirt I put in the bucket last. Okay. Uh, that t-shirt I will have to pick first. So last in, last in, first out. Last L in I F first out O. LIFO. So this concept is known as LIFO, and the stack usually follows this principle. So a stack, I can say in stack we follow last in, first out. Now we are going to talk about application. Firstly, stack can be used to express the expression evaluation and conversion. So expression evaluation and conversion is basically uh, the computer. If I write a mathematical expression like 2 plus 3 into 5, the computer does not process it the same way we does, same way as we does. Because the computer first convert it into the postfix form and then evaluate it. So it's using this. So I will go through briefly in the next lecture. Also an application. So we can see the backtracking as in if I want to go to the center of the maze and there are multiple paths. So checking a single path, and if I fail from this path somehow, and then coming back and choosing another path. So the backtracking is also the application of an stack. Parenthesis checking. We write many codes in other languages like C, C++, Java. There are parentheses like this, and if they're imbalanced, this parenthesis denote the block range, and if there's an imbalance in this parenthesis, so it will generate a compilation error. So it also what the stack does is it also checks parentheses. Function call stack is also used in function calls. Function call because stack stores the address of a last function calls. Like if there are many function I have called, like if function f of x is a function I've called, and in f of x. Def f of x. In this function, I've called in another function called g of x. And then in g of x, I've called another function c of x. In g of x, I've called another function known as c of x. So uh, the stack will contain top of the c, the address of c, because c is the last function which is called. And then it will contain the address of g, because then g was called, and then it will contain the address of f of x. So this is where stack is also used, and string reversal, and syntax breaking. So these are also the applications we will go through briefly one by one in our next video lectures. There are three basic operations in a stack. First, push. Uh, if we talk about push, it simply means we want to push an elements in a stack. So if our stack is empty, we are able to push some elements in our stack. So like I want to push like push 5. Okay, so there will be 5 in the stack. Then I want to push 6. 6 will be pushed into the stack. And secondly, pop. Uh, this means we are able to pop some elements from our stack. So if I write pop, it would automatically pop the topmost elements in the stack, because stack follows last in, first out. And then the lastly, peak. So what does the peak do? Peak prints, or it returns, basically it returns the top most values, topmost element of a stack. Okay, topmost element in a stack. These are the three most common stack operations. The stacks can be implemented using two data structures: first array and linked list. So today we are going to learn the implementation of stacks using array. Um, First, we will create an array name stack. It's an array name stack, and and a pointer which will be pointing to the top of the stack. So I will name that pointer top, and we'll initialize it by -1. Okay, because at the starting there is no element in the stack, so the pointer could be pointing to nothing, null. That's why top is equal to -1. So let us take the diagrammatic view of our stack. So let's imagine that this is our stack, and now for now it is empty, and our top is pointing to -1 because it's 0 is here and -1 is here. So there are basically three operation which we talked about. First was push. If I write push x, so what will happen in our stack? It will happen that the x element, like push 5, the 5 will be pushed into our stack, and the top would be incremented. The top would be pointing to 0, and it will happen because we'll be incrementing top by 1, so it will happen to be 0. And then we'll append 5 to our stack. So now we talk about pop. In the pop, we will decrement the top by -1. So, we'll decrement the top by -1. Top equal to -1. So this is for this code we write. It will be evaluated at top equal to top -1. So if we pop this element, now our top will be pointing to -1 again. And then the last peak. The peak will return the stack top pointer, where the top is pointing inside of a stack. So we'll write its code. We'll create a class. We'll create a class of stack. We'll create a class one stack, so we don't need a super constructor. Uh, then the arguments we're going to call inits. Nothing will be called. So that's it. So this is the constructor, and this will initialize self dot stack, which is our array, and then self dot top, which is our pointer, and as we've talked that it will be pointing to -1. Now we define a function named push, and it will push an x element or element into our array. And what we'll do, we will first increment the top by +1. So not, and then we will append that element into a self dot stack dot append element, and then we're going to peak. So in peak we are going to return the top of the stack of top, and in the oh, sorry stack and top, and in the pop, what we will be doing is decrementing top by -1, and decrementing top by -1, and appending I'm sorry, and popping the element from the array stack dot. Okay, so this is our stack object, and I have to capitalize because now mm, now this is stack implementation, as we have talked. Mm, we have discussed the implementation of stack by using array. Now in the next lecture we will be discussing implementation of stack by using linked list, and then we will be uh, studying the application of stack, like expression evaluation and conversion, backtracking. It's a very important backtracking is very important, and function call, it's a base for backtracking. Parenthesis checking is an also it's used in many things in compiler designs and other. Thank you for